Hello everyone. Today we will be discussing the quick solutions of All India Akash Test Series Test 1A Paper 1, which was held on 13th October 2019. So let us start with the question number 37, which says that if alpha k plus 1 is equal to e raised to the power iota 2 pi k upon n, where n is a natural number and n is greater than equal to 3, then which of the following is correct? So we have to find alpha 1, alpha 2, alpha 3 and so on up to when k is n minus 1, that is alpha n, which is equal to, putting k equal to 0, we will get, let's take e raised to the power iota 2 pi by n common. So we will get k as 0 plus 1 plus 2 and so on up till n minus 1, which is further equal to e raised to the power iota 2 pi by n into sum of this series will be n minus 1 into n divided by 2. So here we can see both n and 2 will get cancelled. So this is equal to e raised to the power iota pi into n minus 1, which is equal to cos n minus 1 pi plus iota into sine n minus 1 pi. Right? Now here, if n is a even number, then this will definitely be 0 and this will be minus 1 when n is even, and when n is an odd number, then it will be equal to 1. Right? So both of these options are incorrect. Now let's talk about alpha 2. So alpha 2 will be equal to, putting k equal to 1, we will get e raised to the power iota 2 pi by n, that is equal to cos 2 pi by n plus iota into sine 2 pi by n. Now we have to find 1 minus alpha 2, and that is equal to 1 minus cos 2 pi by n minus iota sine 2 pi by n. That is further equal to 1 minus cos 2 theta is equal to 2 into sine square theta. So this is 2 sine square pi by n minus sine 2 theta is 2 times sine pi by n into cos pi by n, which is equal to, taking minus 2 iota sine pi by n common, we are left with cos pi by n plus iota into sine pi by n. So if we talk about its modulus will be 2 sine pi by n. So this option is correct, and its argument will be, for 2 sine pi by n we will add 0, for minus iota we will add minus pi by 2, plus for cos pi by n plus iota sine pi by n, its argument is pi by n. So its argument is pi by n minus pi by 2. So option number C is also correct. So correct answer is option number C and D. Next is question number 38, in which we have to find the sum of the series Sn equal to 1 upon 1, 2, 3, 4 plus 1 upon 2, 3, 4, 5 and so on up to n terms. Right? So we have nth term equal to 1 upon n into n plus 1 into n plus 2 into n plus 3. Right? And in the numerator we have 1, which can be written as n plus 3 minus n if we divide here by 1 by 3. Right? So this is equal to, taking 1 by 3 common, 1 upon n into n plus 1 into n plus 2 minus 1 upon n plus 1 into n plus 2 into n plus 3. Right? So if we talk about its sum up to n terms, so that will be equal to 1 by 3 times, putting n equal to 1, we get 1 upon 1 into 2 into 3 minus 1 upon 2, 3, 4 plus, putting n equal to 2, we will get 1 upon 2, 3, 4 minus 1 upon 3, 4, 5 and so on. Right? So these consecutive terms will get cancelled. So sum up to n terms will be equal to 1 by 3 times 1 upon 6 minus 1 upon, putting n, we have n plus 1 into n plus 2 into n plus 3. So This is the sum up to n terms. If we talk about sum up to infinity, then this term will get 0. So sum up to infinity will directly be equal to 1 by 18. So option number C is correct and D is incorrect. Right? Now let's talk about sum of 7 terms. So put n equal to 7, we will get 1 by 6 minus 1 upon 8 into 9 into 10, which after calculating will be equal to 119 upon 2160. So correct answer will be option number B and C option. Next is question number 39, which says that the number of functions f from the set P, that is 8, 10, 12, into the set Q, that is 8, 9, 10 up to 16, such that if I is less than j and I comma j belongs to P, then we have to answer the following questions. So let's firstly start with option number A, in which we have to find the number of functions fi less than equal to fj, right? So we have here set P, that is in which we have elements 8, 10 and 12, and set Q in which we have elements 8, 9, 10, 11, 12, 13, 14, 15 and 16, right? So let's firstly talk about f of I less than equal to f of j. So there are 4 cases in which it is possible. First case is when f of 8 is equal to f of 10 is equal to f of 12, right? Next is any 2 are equal. Let's say f of 8 is equal to f of 10 is less than f of 12. And third is f of 8 is less than when these 2 are equal, that is f of 10 is equal to f of 12. And fourth case, when f of 8 is less than f of 10 is less than f of 12, right? We have these 4 cases. Now to talk about this case, here in this we have to choose any one element from the set Q. So here we can see we have in total 9 elements, right? So this is possible in 9C1 ways. Similarly, this is possible in 9C2 ways. We select any 2 elements from Q and then arrange them in one way. Similarly, here also we will have 9C2 and here we will have 9C3 ways. So if we add all these, so we will get 9 plus 9 into 8 upon 2, that is 9 into 4, plus 9 into 4 plus 9C3, that is 9 into 8 into 7 upon 6. So that is equal to 165. So option number A is correct. Now similarly, if we talk about option number C, that is f of I less than f of j. So if we talk about f of I less than f of j, then only this case is possible, that is 9C3, and that is equal to 84. So this option is incorrect. Now option number B says that f of I greater than equal to f of j. Now in this also we will have similar cases where here we will have greater than sign, right? So in this also we will have same number of functions, that is 165. So this option is incorrect. And for f of I greater than f of j, we have only this case, that is f of 8 is greater than f of 10 is greater than f of 12, that is again 9C3, that is 84. So this option is correct. So correct answer is option number A and D. Next is question number 40, which says that the exhaustive range of the term independent of x in the expansion of x sine inverse p plus cos inverse p divided by x whole raised to the power 10, where p lies between minus 1 to 1. So we have to find the term independent of x. Let's write down the general term, that is 10CR x sine inverse p whole raised to the power 10 minus r into cos inverse p divided by x raised to the power r. So for term independent of x, we will put 10 minus r equal to 0, which gives us r equal to 5. So putting r equal to 5, we will get 10C5 into sine inverse p into cos inverse p whole raised to the power 5. So we have to find its range. So we can write it as sine inverse p into pi by 2 minus sine inverse p whole raised to the power 5. That is equal to 10C5 minus sine inverse p whole square plus pi by 2 sine inverse p whole raised to the power 5. That is further equal to, taking minus outside, we will get sine inverse p whole square minus pi by 2 sine inverse p whole raised to the power 5. That is further equal to, making it perfect square, sine inverse p minus pi by 4 whole square minus pi square by 16 whole raised to the power 5. Now we know that sine inverse p, it goes from minus pi by 2 to pi by 2. So minus pi by 4, it will go from minus 3 pi by 4 up till pi by 4, and if we put its square, then its square will go from 0 to 9 pi square by 16. Is that right? Now subtracting pi square by 16, we get minus pi square by 16 up to 8 pi square by 16, that is pi square by 2. Now we have its power 5, so that is minus pi raised to the power 10 divided by 2 raised to the power 4 raised to the power 5, that is 2 raised to the power 20, up till pi raised to the power 10 upon 2 raised to the power 5. Now let's multiply it with minus 10c5. So it will go from minus 10c5 pi raised to the power 10 upon 2 raised to the power 5 up till 10c5 pi raised to the power 10 upon 2 raised to the power 20. Here we have square bracket, right? So from the given options, it can be seen that correct answer is given in option number A. Next is question number 41, which says that if A, B, C are angles of a triangle such that sine of A minus B upon 2 plus sine of A minus C upon 2 plus sine 3A by 2 is equal to 3 by 2, then we have to answer the following questions. So let's here substitute A as pi minus B plus C. So we will get sine of A is pi by 2 minus 2b plus c upon 2 plus sine of pi by 2 minus b plus 2c upon 2 plus sine of 3 by 2 into pi minus b plus c is equal to 3 by 2. So solving this further, we have cos 2b plus c upon 2 plus cos of b plus 2c upon 2 minus cos of 3 by 2 b plus c is equal to 3 by 2, right? Now so solving this, cos c plus cos d, that will be equal to 2 times cos of c plus d by 2, that is 3b plus 3c upon 4 into cos of b minus c upon 4 minus, now cos 2 theta is equal to 2 into cos square theta minus 1 is equal to 3 by 2. Now this is further written equal to, if we multiply by minus on both sides, so we will get this, that is equal to 2 times cos square 3 by 4 b plus c minus 2 times cos of b minus c by 4 into cos of 3 by 4 b plus c minus 1 plus 3 by 2, that is plus 1 by 2 equal to 0. Now this is a quadratic in cos 3 by 4 b plus c, so its discriminant should definitely be greater than equal to 0. So we have 4 cos square b minus c by 4 minus 4 into 2 into 1 by 2 should be greater than equal to 0. So 4 can be taken common and can be removed. So we have cos square b minus c by 4 minus 1 greater than equal to 0, that is this is greater than equal to 1, which means that cos b minus c by 4 is equal to 1, which means that b minus c by 4 is equal to 0, that is b is equal to c. Now, putting b equal to c in equation number 1, we will get 2 times cos square 3 by 4 into 2b, that is 3b by 2 minus 2 times cos of 3 by 2b plus half equal to 0. From here we will get cos 3b by 2 equal to half, which means 3b by 2 is equal to pi by 3. So b is equal to 2 into 180 degree upon 9, that is equal to 40 degrees. So b is equal to c is equal to 40 degrees. So a is definitely equal to 100 degrees. So from the given options we can say A is the correct option and B plus C is equal to 80, that is D is the correct option. So answer is A and D. Next is question number 42, which says that let A is equal to Aij 3 cross 3 such that Aij is equal to 2 if I is equal to j, and it is minus 1 if mod I minus j is equal to 1, and it is 0 elsewhere. So let's firstly write the matrix A, which is equal to 2 for the diagonal elements, and it will be minus 1 here, 0, 0, minus 1, minus 1, minus 1. So this is our matrix A. So let's look at the options now. A is symmetric. Definitely A is a symmetric matrix. So this is correct. Trace of A is 6. That is sum of the diagonal elements. That is again true. Determinant of A, let's find it. It is equal to 2 times 4 minus 1 multiplied with 2, so that is equal to 6 minus 2, that is 4, which is definitely a perfect square. So option number C is correct. Now A inverse is a skew symmetric matrix. As we have seen that A is a symmetric matrix, so definitely A inverse will also be a symmetric matrix. So this option is incorrect.